So on this question, like I was saying, we've got our cylinder. If they cut the cylinder straight down, you're going to have a straight line here, and it's going to make a rectangle. So that's why it was this one. That's why it was that one. So A was the correct answer. Next one. Number 2. Did anybody get an answer? Did anybody get an answer?
I tried it. I didn't get an answer. The farthest I got was that 15 was like the other half.
That'd be a start. So this whole thing is 30. This is 15. That's a start. And I'm trying to figure out from here to here. So if I know that side's 15 or that segment's 15, does anybody have any thoughts on how I can find the PL? Well, basically I've got a triangle here. And what type of triangle is this? It's a right triangle. And I know 2 of the 3 sides of a right triangle. So what am I going to use to find the third side of a right triangle? Come on, I said if there's anything at all that you've learned this year, it should be this one. Because we've done it so many times. How do I find the third side of a right triangle?
Don't use subtract.
How do I find the third side of a right triangle? A squared plus B squared equals C squared. Good old Pythagorean theorem. I will pretty much guarantee that there's going to be some question that they're expecting Pythagorean theorem. You have a right triangle, you know 2 of the 3 sides. Use Pythagorean theorem. The side you're missing is the hypotenuse, which is the biggest side. So 8 squared plus 15 squared equals C squared. So now just figure that out. A squared plus 15 squared. 8 squared plus 15 squared gives me 289. So 289 was C squared, but I'm not done yet because that's C squared. So what's the last step on this? Not divide.
Oh, you square root.
You square root it. So you square root both sides. 17 is my final answer. So 17. So if you have a right triangle and they give you 2 of the 3 sides of the right triangle, you're going to use Pythagorean theorem. Now there's other right triangle questions. There could be trig questions. There could be special right triangle questions. You know to use this one if you have 2 of the 3 sides. Good old Pythagorean theorem. Next one. Number 11. Point A was located at -1, -5. It says the midpoint of segment AB is point C, which is at 2, 3. What's the coordinates of point B? Now, typically they give you a piece of scrap paper, and the piece of scrap paper is graph paper. So that way, if you do want to happen to graph something, you can do that. I kind of graphed that question over here. I apologize if you're watching on the video because you can't really see over here. But this was the point, -1, -5. This was 2, 3, the middle. And I wanted to figure out where this was. So basically, we're kind of looking at a pattern. From here to here, what did they do? Do it again. So I've got A was at -1, -5. C, because C was in the middle, is at 2, 3. I'm trying to figure out where B is. Now, we've done this, but it was a long time ago. It was probably clear back in like September, beginning of October. It's been a long time. Think of a pattern. What did they do to get to the middle? So -1 to 2, what did they do?
Added 3.
They added 3. So if I add 3 again, 2 plus 3, 5. So I know the x is at 5. -5 to 3, what did they do?
Added 8.
They added 8. If I add 8 again, I get 11. So there's where the new point is. Now, I am probably about 90% sure that there's going to be a midpoint question. It may be a midpoint question like this, where they give you the midpoint and you're missing one of the other 2 points. It may be a midpoint question where they give you the endpoints and you're missing the midpoint. Remember, if you're missing the midpoint, it's just kind of like average. You add the 2 numbers up, divide by 2, because you just want to find out what's the middle. But I'm pretty much 90% sure there's going to be a midpoint, one way or another. Something will say find the midpoint. Now we do skip around a little bit just because 11 was small, it fit on the paper. So they are basically in order, unless there was a question that was small that I could kind of tuck in different places. Number 4, translations. Hey, we did translations just like 2 or 3 weeks ago. And it's actually pretty close to what we just did. Because I've got my original triangle. And then they said the new triangle after a translation. Remember, translation is just like taking something and sliding it somewhere, sliding it somewhere, sliding it, sliding it. So I've got to figure out how did they slide it. And the new G ended up at -1, -3. And I got to figure out how did they slide it. And it's just a slide. So the X part. Was it -8? It slid to -1. So how far did it slide? If it started at -8 and slid to -1.
It slid 7.
It slid 7. So they added 7. 2, it ended up at -3. How far did they slide it on the Y side? The up down. 2 to -3. 5, and it's actually a down 5. So the X went up 7, the Y went down, or -5. So 7, -5, basically. 13 plus 7 is 20. 2 minus 5 was -3. So 20, -3. -2 plus 7, 5. 10 subtract 5, 5. There's your new coordinates. There's your new coordinates. So a translation is just a slide. So they may ask something like this, where they tell you where one of the points ended up, and you got to figure out where it slid. They may say, how far did it slide? They may give you how much it slid, and you got to come up with the new coordinates. But there's probably going to be some form of translation. Questions on number 4. A soccer coach determined that there's a 50% chance that star player Ralph will play in a tournament. The probability that another star player, Dan, will play is 0.48. The probability that both Ralph and Dan will play in the tournament is 0.25. Select phrases to complete the statement. So we got kind of a drop-down thing here going on here. Make this a little smaller. So they give us some information. It says to find the probability that either Ralph or Dan will play in the tournament, first add something and then do something else. Well, this particular formula was on our formula sheet because it said Ralph or or Dan, and we had an overlap, Ralph and Dan. So this is the one they actually give us the formula. And the formula was the probability of A plus the probability of B minus the probability of A and B. So the probability of A would be Ralph. The probability of B would be Dan. Well, that's the first part. So, which one of these three am I going to have to do for the first part? Add 0.5 and 0.48, add 0.5 and 0.25, add 0.48 and 0.25. If I'm adding Ralph and Dan,
Yeah, adding. 0.25.
I'm adding the 50% and the 0.48, because that's Ralph and Dan. Well, 50% is 0.5, so that's this guy. So I'm adding Ralph and Dan together. So right now that looks like a 0.98 or a 98%. But the problem is there's some overlap. There's some cases that Ralph was counted, Dan was counted, they were both counted together. So I had to get rid of the overlap. And this is the overlap. This is the overlap. So to get rid of the overlap, well, this one they gave us a lot of choices. Which one's it going to be? Well, they gave us the formula. Formula says to subtract the overlap, which is Ralph and Dan. So which one of those is subtracting Ralph and Dan, the overlap? 1, 2, 3, 4, 5, 6. So out of the 6, 1, 2, 3, 4, 5, or 6?
4.
It is a subtract, but the overlap of Ralph and Dan was 0.25. So that's what you want to subtract. That's the overlap. Because remember the probability, and we did this last week. This was like Wednesday, Thursday last week. If it's an or, you add. If it's an or with overlap, you've got to get rid of where the two things are together. Because you don't want to count them twice. So right now, between 0.5 and 0.48, some things got counted twice. So I had to get rid of the times that they might be counted twice, which was the Ralph and Dan. So that's the 0.25. That was it on these. Now, like I said, we're going to be going through this week. So tomorrow we're going to be looking at kind of the next page. We'll do kind of a page at a time. So tomorrow I'll start off by saying to work on the next page and then we'll go over it.